First of all, what an amazing keynote, Sabby. Let's give him another round of applause. Really loved the talk. Thank you. He spoke about what he wants you to do. I'll remind you about what you don't have to do. You don't have to unmute to speak today. Isn't that rewarding? I can tell you, I am absolutely amazed to see humans in person. This is just, I'm almost in tears. I'm not in my basement. I'm here with people. I hug people. I shake their hands. It's just absolutely wonderful. I want you to give a round of applause to yourself for being here today. Thank you. It's great times we are in. It's the worst time we've been through. So, pardon me. I want to talk about something we deal with every single day. When we go to work, we have to deal with complexity. We create complexity, not that we desire to, but we often do. And we have to constantly be able to deal with all this complexity every single day. But with us every day, we have something that is probably the most amazing thing in this world, and that is our human brains. The human brain is probably one of the most complicated things, most complex things. And what is really amazing about a human brain is we come up with ideas, and oftentimes people say, how do you figure that out? How do you think that? And it's the same human brain that often gets into this analysis paralysis. And we get tangled up in these emotions and ideas, and we try to really devise a plan, and it becomes really hard to implement solutions. In my family, as my children were growing up, we often had discussions about various things, and almost always, Schrodinger's cat was involved in our discussions. And we often talked about Schrodinger's cat, but I'll bring this back later on, why that's interesting and relevant to what we talk about today. But I want to talk about simplicity. And Confucius said, life is really simple, but we insist on making it complicated. And we have seen this all. I'm sure you've seen your share of people. Some people who will take simple things and make it complicated. And others who will take complicated things and make it even more complicated. But it really takes effort to go in the opposite direction. And the question I want to ask is, why? Why do we want to make things complex? And for that, we have to be really honest. I'll tell you honestly why you make things complex. Because when we do, it feels good. Isn't it? You go to your colleague, you show your design and say, hey, what do you think of this design? And your colleague says, yeah, that's simple. And you feel let down. You're like, what do you mean it's simple? Give it to me, I'll come back tomorrow. And instead they look at this and say, oh my gosh, what are you doing in here? And we're like, yeah, I took time to write it, you better take time to understand it, right? Or maybe you hired an intern from the university and said, come work with us during the summer. When the intern finishes work, when they go back to campus, go with them and see what they are talking to their colleagues in school. They probably are saying, you know the company I interned with? Those people are geniuses. Really? Yeah, I have no clue what they're doing, right? Because we take pride in making things complex. If you make things complex, maybe you're worthy of something. And it's such a misguided situation we are in, isn't it? Or you go home and tell mom, Mom, I wrote code today, and nobody understood it. And mom says, kid, I knew you're going to be successful one day, right? So we take pride in creating complexity when we should be going in the opposite direction oftentimes. As Einstein said, any intelligent fool can make things bigger, more complex, more violent, but he says it takes a touch of genius and a lot of courage to move in the opposite direction. And I want you to focus on the most important word in his quote. And that word I want to underline is not genius. It is a lot of courage. It takes courage because how many times you are in a design meeting and you propose an idea and you get ridiculed for that. And people say, gosh, that's too simplistic maybe. We want to put clutter around it because we need this to look really good. And it requires courage for you to stand up and say, no, I want to solve the relevant problem for the users. This is adequate. I don't want to do anything more complex. And so, what is simple really? The first thing I would say is, simple keeps you focused. Let's think about this for a minute. Let's say you're working on a code. You're not quite sure what Java API to use. So what's the first thing you do? You want to search for it. And as we know, there are several search engines out there. I won't mention the names of those. But in some search engines, you open the search engine, the first thing they want to give you is the gossips of the day. The screen filled with all these news, isn't it? And you went to search for an API, and you see these messages, and now you're scrolling. Oh, look, what did Musk do today? What's happening over here in this other place? What is Trump doing today? And we completely get distracted and derailed. 15 minutes later, what was I thinking about? Oh, that Java API. Or there are other search engines. You go in, they show you beautiful pictures. Now you're curious, where did that picture come from? Let me ask you this question. How many of you use Google to do your searches? Yeah, everyone. You know why you use it? Because you value your time. Because when you go to Google, you see this. And when you look at this page, what does it say? It's got a box, type something in there, and search. Can you imagine the first day when somebody went with this and said, boss, I've got the page designed. What in the world is that? Well, I know you're going to ask me, so I put, I'm feeling lucky. Well, you should. Let me ask you honestly, very genuine question. How many of us will have the courage to create that? Very few, isn't it? There's one person, right, or two people. That's why we have few in number, right? Very few have the courage to create it. Because we will create this and we'll doubt ourselves. That cannot be good. It is not enough. It doesn't have enough things. But this is a work of courage. I wouldn't call it a genius. Because it takes courage to say, that's it. Make no mistake, behind that button, there's a huge amount of complexities and algorithms and AI and servers and clouds. But they said, that's our problem. But we want to give you effectively what you want to do. What are you here for? To search. Well, then search. If you want to know what Trump is saying, search for it. We're not going to distract you with things that you don't need to care about. That is courage. If we can carry that in what we do every day, I think we can move the needle one step towards simplicity. Well, moving a little further on this, here's a beautiful quote. Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. So the question I ask every day when I go to work, when I sit with my clients and we design, I'm asking the question, what can we remove? Oftentimes people want to ask, what do we add? No, what can you remove? What can I remove from this so it still serves my problem and is effective? So a good question we can ask every day towards simplicity is, what can we get rid of? The clutter, the complexity, all the things that distract us, all the things that make it really hard for us to evolve the code and to deliver the value to the customers, what can we remove is the question we want to ask continuously. Simple eliminates accidental complexity and hides inherent complexity. This is one of the reasons why I'm a big fan of functional programming. Because in imperative style of programming, it has accidental complexity. Functional programming removes that complexity from us and makes the code easier to understand and easier to follow, and it distills us down to the inherent complexity from the problem domain that can be really effective. So simple keeps you focused, but simple also eliminates the accidental complexities from around us. But simple also fails less. It's robust. And when we design something simple, we are much more effective in using it, and it fails less. A common interview question probably you have heard people ask you is this. They ask you the question, why is this shaped round? You probably have seen this everywhere you go, but why is these things that cover the hole, why is it round in shape? Well, one answer often people give is that this will not fall into the hole. That's a very important requirement, I think, right? Imagine you're the worker, and you finish the job, and you get out, and somebody puts the lid, and it goes plop all the way down. And now you're like, darn it, now you got to go back and get it now, right? Not a fun day. So you don't want this to fall in. But imagine this for a minute. If the requirement for proposal is sent to you and says, design something that doesn't fall in, how many of us would want to design that when we can design any of these things? Because these things will not fall in also. And maybe this will make more money in a contract, right? But as it turns out, one of the reasons why this one actually happens to be a better design compared to the other ones is there's one additional feature this one has. And that is when you're done, you just roll it on and you're done. You don't have to position it in a direction. Everybody is out. Let's go home, folks. I got to close this lid. How do I do this now? Just roll it on. Let's go. Simplicity again. So it's not only that it doesn't fall in, it just falls any way you want to. There's no directional component to it. It becomes easier to roll it over. But simple is also elegant. And there is a sense of elegance. When you do something simple, there is calmness. It's like, wow, that's elegant. Why is this the most amazing painting in the world? Why do we admire this and say, wow? And you know why? Because nothing in there. This is the work of art where there's nothing to clutter. There is no jewelry on her. There is no earrings or tongue rings or whatever you can think of. There's nothing jittering except for this most natural, beautiful smile. There is nothing to remove. And that's why we appreciate this as the most beautiful painting. That is elegant. And the elegant comes from not having clutter, not having things to distract us. What if we can develop software, code, all the way from code all the way to the UI, where it can be elegant, nothing to distract, to keep our focus into it, so we can get our work done and be productive to the users. And this brings me to one experience. I call it the architecture's dilemma. I was visiting Boston, and I was absolutely mesmerized by this particular building. I stood there for a long time. I wouldn't move until my family said, Venkat, you need to come with us now or we're going to call the cops on you. And I said, well, I can't imagine not looking at this building. The building I was looking at was the Trinity Church. And you may say, what's a big deal about this Trinity Church? It looks like any other church. What drew me was not the church, actually. If you ever go to Boston, next time you are there, find this place, the Trinity Church, and next to it is a building. It's the Hancock building, and my camera didn't do justice to this, but the designer, the architect of this building, sent a proposal to the city saying, I want to build next to this church. And they said, no, we're not going to let you to build next to the church. It's like, why not? Well, the church is beautiful, and if you build next to it, it's going to take away the beauty of the church. So no, we cannot give you permission. And the architect said, I will build it, and when I am done, the church will only be more beautiful, he said. And I was mesmerized, honestly, staring at the reflection of the church on that building. It was so elegantly placed in an angle. And the church was absolutely beautiful and reflective. I just couldn't take my eyes off of the church reflection. I didn't care about seeing the church. I was focused on the reflection. I'm like, this is great. And my wife is like, what's fascinating to you about this? I'm like, look at this. What a work of genius in this particular case to place it in an angle where the reflection comes off of it. And that to me, again, is a creative thinking. You didn't do anything extra, but just take things and enhance it. That becomes really nice. But simplicity has to be evolved. And this is what we do as programmers every day. We incrementally develop stuff and evolve it. And so Richard Feynman says, if you cannot explain something to the first-year student, then you haven't understood it. And this is one of the things we do oftentimes. We try to explain things, and when we find, oh my gosh, that's really complex, isn't it? Well, case in point, I was interested in writing a book on Java 8, functional programming, right about the time when Java 8 was being released. And I was really interested in introducing some concepts. Occam's razor says if you have two equally likable solutions to a problem, choose the simplest one. So we all tried to bring simple ones. So as I was working on this book, right in the middle of the book, I got an idea. I said, what if I can write about tail call optimization? Well, you know this. Java doesn't have tail call optimization. It didn't, and it doesn't now, even still. But in the middle of writing this book, I said, what if I can show how to do tail call optimization in Java? And as I was writing this book, I normally write my books in about 2 weeks. I don't have time to write. So usually, I would find that there is an opening in my schedule. I would lock myself in my room. My very kind family will not see me for 2 weeks. And I would wake up about 3 or 4 in the morning. I'll just keep typing away until 2 weeks is over. And they very politely slide food under the door. And I would grow a beard during the time. Every civility goes down the drain. Occasionally, if I don't ever shave, my children would say, are you writing another book, Dad? It's like, no, I'm just growing the beard. So I was frantically writing this book over the 2-week period. And in the middle, I said, hey, what if I show how to do tail call optimization? So the time window was very short. So I went on to realize, hey, here is a factorial as an example. And if I say, if it's a 1, return number, otherwise number times factorial minus 1, oh, that's a recursive call. But unfortunately, it's going to fail with the stack overflow exception if the stack size is too big. The code is elegant, except it doesn't work. But how do I make it work as a tail call optimization? Wouldn't it be nice? And I've read through books like Structured Interpretation of Computer Programs. And in this particular book, they talk about 3 different things. A procedure you can write, and it can run as an iterative process, iterative procedure, iterative process. Or you can write as a recursion, and it runs on a recursion. Or you can write as a recursion, but the compiler can transform into an iteration. You get the best of both worlds. Because you write recursion, expressive, it runs as iteration, no stack overflow. I said, that's a nice idea. I've used this in Scala. I've used this in Groovy. I've used this in Clojure. And I said to myself, if these languages can do, maybe I can do it too. And I'm sure every one of us have had the idea in the past, isn't it? Maybe I can do it. So I sat down to write the code. So I said, here's a tail call. And I said, hey, here's the factorial, and go call the invoke on the tail call. That worked really well. Then I said, I want to work a little bit more on this code. And I counted my time. I've been coding nonstop for 10 hours to make this work. And after 10 hours and another day of work, I came up with this solution. And I said, here's a tail call class. And eventually, I came across this one. And I want you to just focus on just the 3rd line from the bottom. Call complete equal to current dot is complete. On that one line, what I'm doing is I'm saying, go get me the next call, and if the call is completed, great, otherwise get the next call and evaluate, next call and evaluate. Only one problem though. When you look at that line, I'm mutating call complete. Well, here's the problem. Until that page in the book, I was telling the readers, avoid mutability. Don't mutate. Honor immutability. And now, what was I doing? Mutating. And I was struggling with this. And I think I came with the best answer, in my opinion. I put a footnote, and I said, dear reader, do you notice I'm mutating this variable on line number 71? Turning this into immutable code is left as an exercise to the reader. I thought that was a good solution, which would have worked really well 7 years ago or 70 years ago. With the social media, won't fly. Like, dude, what are you talking about? Show me an example. Then I said, second solution I thought was much better. Dear reader, do you notice I'm mutating on line number 71? My suggestion to you, avoid mutation except when you cannot. I thought that was a reasonable answer too. And I realized my code really stinks. And I said, okay, I got to really take a pause on this. I'm going to go find somebody, ask them for help. Then a day later, I was on the treadmill jogging, and my thought was detached from this. I was slowly thinking back, and I said, oh my gosh, I can actually use things I already was talking about in the chapters before, and I can bring this back. So right on the treadmill, I had an inspiration, ran through the floors of my house, refactored the code. In 10 minutes, I had it working. And essentially, I realized I can do tail call optimization using an infinite stream. It only took me about 2 or 3 days of my life to figure this out, which is really simple, but I couldn't really think about it on the day number 1. And I started thinking, why did I not come up with such a simple solution in the beginning? This is kind of obvious, it was like the moment, but why didn't I think of it? And the answer was, you have to evolve. You have to work your way towards it. And Einstein said, everything should be made as simple as possible, but not simpler. But here's the conundrum I often face. I write code and I say it's simple, and a colleague of mine comes and says, why are you doing it? And I'm like, what do you mean? And they say, why don't you try this one? I'm like, oh. And I try it, and it works. And it's simpler than what I thought I could do. So the question is it really simple, or can it be simpler? And I figured simplicity, after all, is a Schrodinger's cat. Because it may be simple until somebody shows it could actually be simpler. But I think every bit of the effort to make things simple is absolutely important. If you make things simple, you make a better product. But more important, you learn the skills to make things simple. And every single day, we fight that battle. We get better. We develop our skills to actually make things simple. That's absolutely worth it. Simple makes things easy, but making things simple is not certainly easy. But I'll leave you with the words of Da Vinci. He, after all, said, the simplicity is the ultimate sophistication. And I think it's very well worth putting our efforts towards it. So let's try to really make things simple. Enjoy the conference. Thank you.